My name is Brian Burke, Commercial Manager for Brembo North America.
So Brian, today we're talking about regenerative braking. And first we're going to talk about what happens on a conventional brake. Tell me what you've got here and what kinetic energy is.
Basically, kinetic energy is the energy that's from the motion of your vehicle. So as you're traveling down the highway at 70 miles an hour, there's a certain amount of energy that's in your vehicle and the motion that's associated with it. What our conventional braking systems do is they translate that kinetic energy into a heat. Okay, and the way they do that is through the braking system. So as you apply your brake, the brake caliper, which is the red device that you see in the case of Brembo red or yellow or some fancy color, actually squeezes against the brake pads, which squeezes on the rotor, and then the pad, as the rotor is rotating and spinning like your car is moving, your wheels are turning, it actually rubs and creates friction on the brake rotor. Now, this iron brake rotor actually takes that friction, okay, and acts as a heat sink, okay, and so as it's rubbing, it gets hot, just like when you rub your hands together, you generate friction and they get warm. It's the same principle, but onto the iron. So we actually have in our conventional systems a very heavy piece of cast iron, which acts as a heat absorber or a heat damper to absorb the heat that's created by the friction.
You said that some of these can get up to 900 degrees Fahrenheit on this racetrack that we're at today.
Yeah, easily 900 degrees Fahrenheit, and that's very easily achievable. So that type of temperature, Brembo designs their rotors so that we can cool the rotors efficiently to try and get rid of that heat that's generated.
And it goes in here?
Yeah, what will happen is as the air comes in from the vehicle as you're traveling down the road, the air would flow in from the inner diameter of the rotor right into this channel here, and we design the rotor specially so that we get a good flow of air through this chamber in the middle of the rotor that you can see right here, and then the air passes out through the outside of the rotor, taking away the heat that's stored up in this rotor.
Talk to me about regenerative braking, and right now we hear about regenerative braking on hybrids. Mm-hmm. How is that different?
Yeah, regenerative braking is a revolutionary principle that's been around for a little while, but basically the principle behind it is to take this energy, this kinetic energy, and rather than wasting it with heat energy, we take that energy and convert it into another usable energy, such as electricity or something that we can store up and again later reuse, because the heat energy that's created in this rotor is never reused again. The rotor just stays hot all the time until you park your car in your garage and you come out the next morning and it's cold again. Those magnets, you know, if you try and put two magnets together opposite and you push them together, that you can't do it. Okay?
No one in the world can.
No one in the world can get them to stick together. Well, they use that principle to create the force without actually having friction. Okay, you create that force of stopping, but without actually generating the heat and the friction. And instead, you create some electricity through basically a generator type system, which takes that electricity and then the generator actually converts it into electricity, and then it's transferred into a battery pack, which is stored in the car. So next time you pull up to a stoplight, after you brake at the stoplight, you're storing up energy, and then when the light turns green and you press the gas, now that energy can be introduced back into the electric motor in the other direction and accelerate you forward. So it's really a revolutionary principle. The main reasons we see it on hybrids is because right now it's only really able to be used on vehicles with electric powertrains and where you have battery storage capabilities.
Because you're taking kinetic energy, transforming it into electricity, and able to store it in the battery that's in the hybrid.
Correct, correct.
What is Brembo working on with regenerative braking on conventional vehicles?
Well, on conventional vehicles, Brembo is working on some advanced regenerative programs and some electromechanical braking systems. Right now, we do not have any regenerative braking systems in production for the mass market. My feeling is a lot of the technologies that are being used in Formula One racing right now, which is the highest level of racing, they've forced the Formula One rules to adapt a regenerative type braking policy. So the rules mandate that the manufacturers must now create in racing a way to do what will eventually be applied to the automotives and store up this energy and reuse it.
And how are they going to do that?
Well, there's actually four main methodologies. There's a mechanical methodology, and the simplest analogy I can use is if you know the rubber band airplanes where you, as a small child, you take the propeller and you wind it like this, and you keep winding it, and the rubber band coils up, and then when you let the propeller go, then the plane takes off. There's a concept that's very similar to this methodology, which is a mechanical methodology for creating regenerative braking. So it's like the idea of pulling a rubber band and then you got energy in it, then you let it go and it shoots away. fundamentally, this is one of the concepts that's being evaluated right now in racing. Some of the other concepts are using advanced devices that connect to the engine's crankshaft, and these devices that connect to the engine's crankshaft have some very high-tech components in it, which, as the crankshaft's rotating, can apply a charge or an electromagnetic field inside a kind of a vacuum-type system, and then create electricity in a generator method similar to what we talked about that's on some of the hybrid vehicles, like the Toyota Prius, for instance. I think right now, and I'm not certain of this, but most of the teams are leaning towards the electricity method in what I'll call a electrical methodology of regenerative braking, as opposed to the mechanical one like the rubber band that I mentioned.
And the electrical one is the what?
The electrical system is what I talked about with having an electromagnetic field, and the magnetic idea where you have magnets that can repel each other and actually create a force to stop the car.
But in a conventional car, where are they going to put that electricity?
In a conventional car, actually, the way in Formula One, the way that the energy is actually possibly going to be reinduced is they'll actually have a device at the wheels, at the wheel ends. There's one technology that allows it to be applied with a motor at the wheel ends to turn the wheels. There's another methodology where they actually apply it right at the crankshaft. So just before the transmission of the vehicle, they would apply a type of mechanism that would allow the transmission to be energized, or spin faster to give them more energy to propel the vehicle forward.
Will this help on miles per gallon at all?
This will help tremendously on miles per gallon. It's really will be a very big step in terms of hitting the EPA targets and such. And right now, it's obviously, as any new technology, quite a costly technology. But as things progress, for sure, this will be a huge advancement because you're getting free energy to some extent, or energy right now that's not currently being used for anything. You're using it for something very valuable. Has a huge potential. I really see this as being as revolutionary in the brake industry as ABS or anti-lock brakes were. If you remember back in the late 80s and early 90s, this was the biggest brake revolution. I think this will be the next generation brake revolution.
Brian, thank you very much.
No, thank you.